Bismillahirrahmanirrahim. This is part E of our 7th lecture on Descriptive Statistics and Islamic Approach. In this lecture, we will compare growth rates across nations to decide whether one nation has genuinely superior performance in terms of growth rates. We discussed this question in an earlier lecture where we compared two countries, and since growth performance differs across years, some countries being higher in some years and lower in other years. So how do we decide whether one country has superior growth performance? In the previous lecture on this topic, we decided to use the median growth rate as the criterion. But this was just an arbitrary choice. And in this lecture, we will look more closely at this question and ask whether the difference is significant in the sense that we have been studying in this lecture. So to explain how this is related to association, the issue can be posed as saying, is being Turkey associated with having a higher growth rate? And this is the question that we will be studying in this lecture. It's easier to understand what we are doing if we look at scores in games and consider the question as an issue of whether the higher score of one player is due to skill or whether it is due to luck. This becomes easier to understand intuitively, so I will discuss the question in this context first. A hypothetical example, suppose I have in a game two cricket players, one of them scores 75 runs and the other scores 25 runs. Can we conclude that the player who scored the higher runs is more skillful? Well, obviously not. In one game there's lots of chance factors, and the more skillful player can easily end up with the lower score. So we need to compare scores across a number of games to be able to judge whether these scores reflect the skills of the player. So here we look at one case where two players, hypothetical players, we compare their scores in 10 games, and we find that in all 10 games, one of the players scored more runs than the other player. So does this imply now that Javed is more skillful than Yunus? Well, there are, in some cases, this is possible to conclude. Let us assume, to begin with, the favorable case that these are the numbers for the same matches. Both players played in the same matches, so that the environment is more or less the same. This makes the scores comparable and minimizes the confounding factors, but it does not eliminate them. Assume away the complications that might arise due to confounding factors and many other real-world things, and we consider the null hypothesis that both players are equally skillful. In this case, either player could have a higher score with 50% chance. And if this is so, then the chance of 10 victories in a row for one player is 1 over 1024, 1 over 2 to the 10th power. So the p-value of this comparison is 2 over 1024, because the tail events are all victories for one player and all victories for the other player. There are two tail events. And this is highly significant according to the standard conventional p-values. And so we can conclude that Javed is more skillful. But this is a judgment based on the numbers alone. It is not a scientific inference. We cannot really prove this. It may not even be true. It may be wrong for a number of reasons. Somebody who looks at the two players play will have access to qualitative factors. He will be able to look at their style, performance, and many non-measurable factors, and may be able to come up with a better a better judgment which doesn't depend on the scores at all. Before proceeding to the main topic, I would like to make a few remarks about the philosophical background of the development of this subject of statistics, which is part of the social sciences in the early 20th century. It is too complex to be covered in this lecture and in fact in many books, but it is worthwhile going into it very briefly, that these social sciences that we are studying today are creation of the early 20th century, and they were based on this philosophy of logical positivism, which is a failed philosophy. And that's why there are serious problems in the foundations of these subjects like statistics. So very briefly, abuse of power by Catholic clergy led to disenchantment with religion. It led to a split, first of all, between Protestant and Catholics, and then violent fights between the two, which ultimately led the public to and elite intellectuals to reject religion. And if you reject religion, then what happened in Europe was that they promoted science as the new religion. And that led to the belief that science leads to certain knowledge. In fact, this is not true. Science is only some guesses about reality, but it was promoted to being certain, and that was done via the philosophy of logical positivism. And this philosophy denies the unseen. It says only what we can see can be trusted, and it denies the emotions, the heart, the integrity, the honesty, the qualitative and the unmeasurable characteristics, because they cannot be seen. So positivism says that we should not use these. And this leads to very distorted social sciences. And in statistical theory, it leads us to a theory which deals only with the numbers and denies the reality behind these numbers. And it creates a pretense of objectivity while being highly subjective. And so those are the kinds of problems that arise because of the positivist philosophy which shaped the birth of social sciences and statistics in the early 20th century. But this is just a hint and a clue. We can't really go into the details and the depth of this topic, even though it's very important. To explain how this philosophy applies to what we are doing, we just look at the cricket scores. Actually, what we're trying to do is measure the skill. And the score is an indicator of the skill, but it is a very imperfect one. A very skillful player can get a low score. A player with very few skills can happen to get a high score. So if you have an experienced observer, they can look at the players and they can judge their skill without actually looking at the score. The score is an indicator of the skill, but they are not the same as the skill. But the philosophy of positivism attempted to replace the unobservable by the observable and to make the two equal. So the skill is measured by the score, but actually the score is the skill. That is what the positivist philosophy said. So this occurred across the board in many different fields. So for example, in the academia, instead of looking at the unobservable, unmeasurable, quality of research, we say, okay, let's just count the number of publications and look at the impact factor to assess the quality. So this is a half-truth. I mean, there is something to this. The number of publications and the cricket score, these do actually indicate skill, but the relationship is imperfect. And so the half-truth is more dangerous than an outright lie. And the real problem is the conceptual confusion. Instead of thinking that there is a skill and there is a score and these two are different, one starts thinking that these two are the same thing. The skill is just the score. And that's really the problem that emerges from positivist thinking. So just to explain how the numbers can be misleading, there are many situations in which exactly the same set of scores would lead to different conclusions. For example, if there was a trend in the scores of one of the players is increasing over time and the other one is decreasing, then we might say that, well, yes, these numbers measure the skill, but the skill is actually changing. One of the players is gaining experience and the other is growing older and becoming less, making more mistakes, for example. Also, there can be confounding factors that which make the matches non-comparable. For example, if one of the players scores for international matches and the other is one for domestic matches, then since the level of the challenge and competition is different, the scores might have different meanings. And so because of the many possible problems in comparing scores, when we come to a judgment, it is just a judgment, it is just a guess which is based on some information. And in the early times of the study of the probability, it was understood that this was called the art of conjecture, that this is not a science, it is a judgment call, and judgment can be helped by making some calculations. So the numbers are not useful. It's not just that we think and we come up with the answer. We can actually make some calculations which help us to make decisions. But these are, again, finally, it's just a judgment and it's just a guess. It is not a objective scientific inference of the strong type where it cannot be denied, and it is certainly not certain. This preliminary discussion, we come back to the original problem of comparing growth rates of the two countries. WDI dataset, the World Bank dataset on growth rates, it is a bit surprising that the complete data from 1960 to 2018 exists for about 18 countries. This is surprising because data on GNP exists for nearly all countries on nearly all time periods. And from this GNP data, one can easily calculate the growth rate. So I don't know why the WDI dataset does not give growth rates and gives blanks and missing data on many of the growth rates, when WDI dataset itself has the GNP required to compute these growth rates. But anyway, I will not explore this question. I will just look at these 18 countries. And these are listed here by the country code: Argentina, Madagascar, Greece, and so on. And so basically the data set has 18 countries in it, and it has data from 1960 to 2018. And so previously we analyzed the same data set and we calculated the median growth rates, and this data set is organized by the median growth rate. So Argentina has the smallest median growth and Singapore has the highest median growth. The question we want to look at is compare Argentina, which has the smallest growth rate, to the other 17 countries. Is the difference significant? Can we say that the other country is actually superior in terms of economic performance? Or is it true that the superior performance, the higher median growth, is just purely due to chance and it does not reflect any genuine real-world factor? So again, we apply the same methodology that we have developed for cricket. If there is no significant difference, then the comparison between the growth rates is just like a coin flip. Either country could win that competition. So in each year, it is like a coin flip in which one country or the other will win. If both countries are the same in terms of growth factors, then the chance of either country winning is exactly 50%. So the total data we have is for 59 years. So we just count the number of wins for Argentina. With 59 points of data, 29 and 30 are the middle numbers. So these are the closest to 50%. So if these numbers are observed, then this means that there is no significant difference. And if the number of wins for Argentina is small and the number of the wins for other country is large, then then there will be some significant difference in growth, and we can conclude that the other country is genuinely superior in terms of growth performance. The results of doing this exercise are shown in this table. The we just count the number of wins for Argentina. So this count compared to Madagascar, there's 29 wins. That is 29 years where Argentina had higher growth rate, and the remaining 30 years Madagascar had higher growth rates. So this is about the same. So obviously there is no reason to believe that Madagascar had a better growth performance. Similarly, if you look at the different countries, they have different numbers of wins. Generally speaking, Malaysia is Argentina has the lowest median growth rate, so it has the weakest performance in terms of median growth, and so other countries typically have better growth rate performance. But as we can see from this table, the numbers are not, for many of the countries, the numbers are not that much different from 50%. And so once we have the number of wins, then we can compute the p-value, just like we did in the last lecture where we were looking at the flips of the coin and trying to decide whether the coin was fair. So exactly in that way, we can compute the p-values to see if this difference, for example, Australia has 27, Argentina was superior in 27 time periods, and Argentina was superior in the remaining 32. So this is not really very much different from 50%, and the p-value is 60%, which is very large. So basically this computation of p-value tells us whether or not there is a significant difference between the growth rate performance of the Argentina compared to the country listed in this table. So the results from this analysis show that from 23 to 30 and also from 30 to 36, which didn't occur in the table, but these are all insignificant differences. And there are 9 countries in this range, and they include Mexico and Peru and many others. So all of these 9 countries, we find that there is no significant difference in growth from Argentina. Then we come to 3 countries which had 37 wins against Argentina, 37 years for which they were superior in growth, and 22 years in which Argentina was superior. So here, at this point, 22 and 37, the p-value is 6.74%, which is borderline significant. We might think about whether Guatemala and Chile had a better performance. There might be something genuine, or there might not be. One needs to check more carefully to look at the real world to decide. The numbers by themselves are not enough to answer the question that we are looking at. Then we get from 22, we get to 21 wins for Argentina and 38 wins for Philippines and India. And this reduces the p-value to 3.6%, which is according to the conventional rule that p less than 5 is significant. This shows that this is a significant difference. So Philippines and India are more worth investigating. Then we come to Malaysia, Korea, and Singapore, which have 41, 42, and 44 wins. This gives us very small p-values below 1%, so these are highly significant. So if the null hypothesis is true, that is, there is no significant difference between Argentina and Korea, then 42 wins for Korea is very unlikely. And so this small p-value means that the null hypothesis itself is very unlikely, because if the null hypothesis was true, we wouldn't expect to see 42 wins for Korea. So probably the null hypothesis is false, and Korea actually is genuinely superior and not equivalent to Argentina. So what do we learn from this analysis? That's the key question. So first, we must understand that the goal of statistical analysis is to produce knowledge about the real world, not about the numbers. And that's really the key difference between the positivist view and the realist approach that we are following. So numbers are indicators. Numbers themselves do not contain knowledge about the real world. They are just indicators. So for example, if somebody says that we measure the IQ and it's 125 and that's the intelligence, that's wrong. IQ is a measure of intelligence, but intelligence itself is something different. Similarly, growth rate is a number. It measures something about the economic processes that are going on in the real world, but it's not the process itself, just a number which provides a clue. So once we understand that there's a difference between the economic process of growth and the number used to measure this process, then our data shows that if you look at Peru and Argentina, Peru has a higher median growth and generally higher growth rates, but the data shows that this difference could easily be due to chance. So it's not worthwhile to analyze why Peru had higher growth performance. But this is not true for Argentina and Malaysia. Malaysia has significantly better growth performance. It cannot be explained by chance alone. So there must be some element of skill or perhaps just a more favorable growth environment. Numbers do not give us knowledge, but they tell us about the questions which are worth investigating, which might produce knowledge. So these numbers tell us that Malaysia had significantly higher growth rates than Argentina. So if we study why did Malaysia have superior growth performance, we might be able to find some answer. We might be able to find strategies used by Malaysia which were superior, or some favorable environmental factor which led to a superior performance. In contrast to this, Peru also appears to have higher growth rates, but our statistical analysis says that this could be purely due to chance. So if somebody starts studying the question of why Peru had a larger median growth rate than Argentina, he might not come up with any answer. The question itself might not be meaningful. And so the numbers tell us what are the questions worth studying. Numbers do not provide knowledge, but they point to the direction in which we might be able to get some knowledge.